Now we'll study about the Carnot's heat engine. Carnot was a scientist who developed an ideal heat engine free from all the imperfectness of an actual engine. As shown in the figure, you can see the figure out there. It consists of 4 components or 4 parts. First, a cylinder fitted with a piston which is having perfectly insulated walls and the upper side of the piston, and the piston is frictionless. The base is a conducting base, and a fixed mass of gas, that is the working substance, is filled in the cylinder and some weights are placed on it. The second part is the hot body or the source. It has infinitely large heat capacity at constant temperature T2. This is 1, this is 2, 3, so that it becomes easy for you to understand. This is the hot source, right, which will be providing the heat or the rise in temperature to the working substance. This again is having insulated side walls but a conducting base. Here there's an insulated stand to just rest the working substance over there. No exchange of heat is going to take place. And then we are having a cold body, again the insulated sides and a conducting base, okay, or the conducting surface here. So when you keep it, exchange of heat can take place here. So these are the 4 basic components of the Carnot engine. Now the first process, what we do in the first process is that the working substance in the Carnot engine is allowed to undergo through a reversible cycle, which is called the Carnot cycle, which we'll be drawing here. The cycle has 4 stages. First, the cylinder is kept over the source and the weights are removed so that the gas absorbs heat Q1 at temperature T1 and undergoes an isothermal expansion. This gas is kept on the hot source. Okay, the weights are removed, due to which whatever heat it is taking, because we are removing the weights and this is taking place very slowly. So what happens is that there is no change in temperature because the gas starts expanding. As it is being heated up, it is being expanded. So the temperature is maintained, or the temperature is constant. And because of this, this is an isothermal process. So if we are drawing a curve between these are the axes. We'll be drawing a curve between P and V. Okay, so when we draw a curve between P and V, then at constant temperature, the gas is being expanded, okay, at T1. This will be an isothermal process. Then what happens is, now this cylinder expand kar gayi, this is kept on the insulated stand. And the weights are further removed. Yahan rakh ke, we are removing the weights. Now, as the stand is an insulated stand, the gas expands adiabatically till the temperature drops from T1 to T2. यहाँ तक उसने temperature T1 ले लिया था. यहाँ पे हमने उसको insulated stand पे रख दिया. And again we are removing the weights as the piston is frictionless and the temperature of this gas is T1. Okay, the gas keeps on expanding till the temperature falls to T2. As it will keep on expanding and no extra heat is given to this body, or there is no exchange of temperature, you can say, what will happen? The temperature of this body will decrease. So from B position, it comes to C position. Okay, and this happens at, or you cannot say this is not T2 here. The temperature here becomes as T2. So here what is happening, that the gas is expanding adiabatically. Okay, so when we are looking to the curves previously, also when we were looking to the curves, we have seen the curves between P and V in isothermal and adiabatic process. Okay, now the temperature drops from T1 to T2 and this is shown by curve BC. ठीक है. अब उस कंडीशन में what we do is we are keeping this body again on the fourth process. We are keeping the cylinder on the sink and the weights are placed on it. अब हमने ये सिलेंडर को सी पे रख दिया and we start placing the weights on it. As we start placing the weights, now the gas is compressing and we'll be drawing the curve of compression. As the gas compresses, the temperature increases. But what is happening is that here again at T2, because whatever temperature is increasing, that temperature is being shared with the cold body. So the temperature, there is no change of temperature, and hence again the compression is isothermal compression. Okay, whatever is taking place at temperature T2, and this again gets back the compression of the gas. This is shown by the term the curve CD. We'll make it a little more steeper, and it comes to D. So this temperature is T1 and this temperature is T2. Further, the cylinder is again kept on the insulating stand and the weights are further placed over it. और हमने रखा. Now, when we are placing more weights on it, the gas is compressing and the temperature is rising because no exchange of heat is taking place. So, उस case में the compression is isothermal. Okay, so from D to A. Again from T2 to T1 it reaches. So here A is having V1, P1, V2, P2, V3, P3 and V4, P4. This is known as your Carnot cycle. This entire cycle is known as your Carnot cycle, and this is how you make and explain it. Right?